right, see, Danny asked. All right, so real quick, talking about this, we're doing algebraic expressions. Yesterday we did numeric expressions, which were math problems with numbers. Today we're doing algebraic expressions, so it's still math problems, but with letters. What can you not write in your problem? An equals. Remember, an expression has no equal sign. There's not allowed to be an equal sign in your work or in your problem. All right, what does the word evaluating mean? Because that's what we're doing today. We're evaluating them. What does the word evaluate mean? Morgan?
Solving the problem.
Okay, so we're going to be really careful about that. We're going to define solving, not next week, but the week after. So we are going to solve. We're not doing that yet. That is a little different. What does evaluating mean? Jenny?
To find the value of an algebraic expression by replacing variables with numbers.
Okay, so we're going to find the value by changing the letters to numbers. What am I doing? Like, what's like a simple way to say that in like regular English? Danny?
Changing letters into numbers.
Okay, not quite what I'm looking for. What did you do to your math yesterday?
Finding the value.
To find the value. The way y'all are using the word solve is technically incorrect. We're going to fix that. All right? Y'all think solve means to work it out. Solve does not mean to work it out. All right? Evaluate means to work it out. All right? To work it out and get an answer. When you're solving for something, you're actually going to be doing something else in algebra. That's going to be a whole different direction. Okay? So evaluating means to just work it out. All right, so for this first example, 1, 2, and 3, it says m plus n. Can I add 2 letters? No, that doesn't mean anything. All right, does anyone see what I could do to work this out, though, Brianna?
At the very top, it says m equals 6 and n equals 12.
Yeah, so this right here tells me m is actually 6 and n is actually 12. Now, here's something that's going to be really important that will cost you some really simple points on the test. I need to see when they change. So what is m going to change to?
6.
A 6. So you have to write that down. Plus, what is n going to change to? 12. We have to write that out, okay? I have to see where they're changing. So that would be a point, and then what's my answer? 18. So changing it to the number, that's half of your points, okay? All right, what is number 2 going to change to say, Aiden?
6 divided by 12.
Be careful. What is n?
12 divided by 12.
Yeah, so we got to be really careful there. N is 12, and then we're going to divide that by m, which is 6. And my answer here is? All right. Now, number 3, guys, we've seen this a couple of times this year. That's how you're going to see it a lot in algebra. What is it when 2 things are right next to each other? What operation is it if they are right next to each other? Brianna?
Multiplication.
Multiplication. So, guys, what this really means is 3 times n. Okay, now did they write 3 times n? No, they just wrote 3n. So, guys, when I put in my number, it has 3. What is n? 12. What does that look like right now?
312.
It looks like 312 plus 8. It's not supposed to say that, though. It's supposed to say 3 times n. So what could I do to where it's still 3 with the number attached to it? What could I do to where I know that this is a 3 and this is a 12? Christy? Without putting the dot, without putting the multiplication. Because the problem didn't put the dot, so I don't want to just write in the dot. So what could I do to make that 3 and that 12 separate, Jenny? Yeah, we can say, hey, 12 is separate. I just put parentheses around it saying, whoo, this is something different. Parentheses are used a lot in math. We've seen them a lot for where they're grouping some math together. Like where you're supposed to add first or where you're supposed to multiply first. Here the parentheses aren't used for math. They're just used to separate. Are we okay with that? Okay, so what operation am I going to do first here? What operation am I going to do first here, Danny? Multiply. And I like that Danny did not say do your parentheses first. Because is there any math inside of the parentheses? No. This is not a parenthesis math problem. This is just, they're separate. This is still multiplication. Okay, so very good job, Danny. So we're going to multiply first. 3 times 12 is? 36 plus 8. And now I can add that and get my answer, which is? 44. Okay. Moving it down. On number 1, what's my problem going to say? How am I going to set that problem up? What should it say? Cheyenne?
So this is going to be
3 to the second power. Very good.
Plus 4 times 6.
Perfect. Now, guys, does this mean that B is always going to be 3? From now on, whenever you see a B, you're going to write 3. No, just for these problems that go with this direction. Okay? All right, so what do I need to do first to work this one out?
Exponents.
Thank you, Josh. Let's try raising our hand. What do I get when I do that exponent, Josh?
9.
9 plus 4 times 6. What am I going to do next here, Aubrey? Mm-hmm. 4 times 6, so I get 9 plus 24. And then for my answer, 33. Y'all are checking my math, right? Sometimes when I go fast, I miss it. All right. Number 2, what should number 2 say? Macy. 3 to the second power. Okay, what's A going to be? 9. So, guys, the way that you would read this would still be 5 times 9, even though I'm writing them next to each other. We would still say 3 to the second power plus 5 times 9 minus 20. Okay? It did not have a dot, so I did not add a dot. I just put those parentheses so I know that it's not 59, it's 5 times 9. All right, what am I going to do first here, Chris?
We're going to do the 3 to the second power.
3 to the second power, which is? 9 plus 5 times 9 minus 20. What am I going to do next? Emma King? 5 times 9. Now, guys, what I like here is you notice, like, usually, please excuse my dear Aunt Sally, would start with parentheses, but was there any math inside those parentheses? No, so we did the exponent. Now we're doing the multiplication. So I get 9 plus 45 minus 20. And what are we going to do next here, Kayla? 9 plus 45, which is 54 minus 20. And my answer, Kayla? 34. Okay. Good so far? All right. Number 3. Brianna, set it up for me.
9 times 12 divided by 2 times 3 in the parentheses.
Perfect. So we have 9 times 12. I'm putting those in parentheses, not separating them. Now, this is an example. So 2 times 3, since it's already in the parentheses, I would allow you to change that to a dot. Okay. If you put the extra parentheses, that's fine. This just avoids all the extra parentheses going on. Are we okay with that? All right. So order of operations here. Order of operations. What should I do first, Macy?
2 times 3.
We are going to do 2 times 3 because this time, is there math inside the parentheses? Yes. Is there math inside these parentheses? No. That's just a number. That's just multiplication. So we have 9 times 12 still in front. Divided by 2 times 3 gives me 6. Okay, what are we going to do next from here now? What am I going to do? Owen? 9 times 12. And 9 times 12 gives me? 108 divided by 6. So my answer is 18. All right, good job. All right, for number 1, it says again so y'all are really going to like algebraic expression word problems because the expression is the problem, right? So when I read this, it says a Gentoo penguin can swim at a rate of 17 miles per hour. It's asking how many miles. That's going to be important for when I answer my question in a sentence. Can a penguin swim 4 hours? Use the expression RT. So how am I going to work it out? With RT, where R is the rate and T is the time. So I'm going to write down RT. If they're right next to each other, what does that mean I'm doing? Multiplying. What is R? 17. It says the rate is 17, so I'm going to say 17. What is T?
4.
The time, which is 4 hours, so I'm going to put 4 All right, when I multiply those, 17 times 4, what did I get? What was that? 68. Thank you. So 68 is my answer. The problem told me how to work it out. That's nice. We got to write a sentence, though. What can my sentence say? Delaney?
We get to pick can swim 68 miles in 4 hours.
Taken to penguin can swim 68 miles in 4 hours. All right, that's 68 miles being the answer we just found out. Okay, questions about number 1, word problems. All right, number 2, a clothing company charges $6 to make a pattern for an order. How many times am I paying that $6? How many times do I need to pay that $6? Just once. It says the $6 is for the pattern, and then it's $11 for each t-shirt that you put the pattern on. All right? The expression 11N plus 6 represents the cost of N t-shirts. So what does N stand for? The t-shirts. Find the total cost for 5 t-shirts with the same pattern. So it tells me to use 11N plus 6. Does it make sense that it would say 11 times N if it's $11 for each t-shirt? But then I'm paying $6 just for that pattern. Okay. So that's only one time that we're paying that. What does it tell me to use for N? N t-shirts, and then it says 5 t-shirts. So I'm going to change that to 11 times 5 plus 6. 11 times 5? 55. Plus 6. All right, make sure you write that set, 55 plus 6, and then underneath we can write our answer. So what would be a good sentence for this one, Josh?
The total cost of all 5 t-shirts is $61.
The total cost for 5 t-shirts is $61. I'm going to say 5 t-shirts cost $61. Either way is perfectly fine. Okay. Questions about the notes? All right, what I need for you to do, guys, I need you to get out a piece of paper. Please get out a piece of paper. All right, flip your notes over and make sure you have a piece of paper. Flip your notes over and make sure you have a piece of paper. Alright, so the first thing on the back is just filling in the chart. We can do this part on our paper. I'm fine with that. So my chart number 1 says 5D plus 2C. It asks for the variables. What are the variables on number 1? C and D. Alright, what are the numbers on number 1 that are being used?
5 and 2.
5 and 2. What are the operations on number 1? Macy? Addition. Kayla? And multiplication. Remember that 5D together is multiplying, the 2C together is multiplying. So I'm going to put addition and multiplication. I'm just going to write it with the dot instead of writing out the words completely. Okay, do you see why I needed to include both of those? So there's a little tip for numbers 2 and 3. All right, we're going to skip down. What we have this paper here for is for the next ones. All right, the good news is you don't have to get out your textbook, but I do want these worked on a separate sheet of paper. All right, so we're going to, on our paper, if we can go ahead, label this. It's variables and expressions is what it says at the top. So I'm going to write variables, just so I know that it goes with that worksheet, and expressions. All right, and we're looking at number 4. Okay, remember, I have to see where your letters change to numbers. I'm not going to make you write down the problem, but I need to see where your letter changes to a number. So for A, we're using 3. For B, we're using 4 on all of these problems. So how would I write down number 4 on my paper? What would I change that to say?
10 plus 4.
10 plus 4. And you're actually going to write that down. I know you can do that in your head, but I need to see where the B changed to a 4. And 10 plus 4 gives me 14. Okay, so let's look at number 5. For number 5, how would I set that one up? Brianna?
2 times 4, or no, 2 times 3 plus 8.
2 times 3 plus 8, because the A changes to a 3, making sure we're not adding a dot unless we need to. All right, 2 times 3 is 6, and 6 plus 8 gives me 14. Please make sure you're showing me where it changes, your steps in order, and then your answer. All right, let's do one more. Number 6. How would I set that one up? Kayla?
4 times 4 minus 5 times 3.
Okay. Order of operations, what would I do first here? What would I do first? Chandler?
Me?
Mm-hmm.
4 times 4.
4 times 4, which gives me 16 minus 5 times 3. What would I do next? What would I do next, Tucker? Multiply the 5 and 3. So now I have 16 minus 15. And then my answer is still doing one operation at a time, just like yesterday. The only difference is you're given letters, you change them to numbers, then work it out.